In this football analytics video, we're going to explore NFL quarterbacks. In particular, how we determine who the best quarterback is in a given week, in a given season, or in their career. The first step will involve comparing NFL quarterbacks using the passer rating metric, which will be defined next. We will compute this metric within R by using some built-in commands like adding, subtracting, multiplying, and dividing. We'll use a sort function within R to order the passer rating from highest to lowest so that we can see who is best and who is worst. We will also go beyond this and evaluate the relationship between passer rating and wins. And this will give us an opportunity to apply some new functions within the plot function to add some features to the chart. Now, in terms of who the best quarterback was in the NFL for any given season, it depends on when you were looking at it. In the 1930s, the best quarterbacks were considered ones who threw the most yards. After that, in the 38 to 40, we looked at, or the NFL considered, the highest completion percentage as the most important. Between 1941 and 73, it was more about comparing the quarterbacks to their peers in any given week. So they would have to wait until all the games were over, and then they would see which quarterbacks did better than others. But in 1973, a group was commissioned within the NFL to create a new passer rating formula. And the formula ranges from 0 to 158.3. It does not include things like fumbles, rushing yards, sacks, wins, or even the number of Super Bowls that a player has won. Now, the passer rating formula contains 5 parts, or 5 components: completions, attempts, yards, touchdowns, and interceptions. Again, it does not include things like fumbles, rushing yards, or Super Bowls, or even the number of games won. In order to understand how this equation breaks down, there are 4 parts to it. The first part is commonly known as A, which is completions divided by attempts minus 0.3 times 5. The second part, called B, looks at yards per attempt minus 3 times 0.25. The third component, known as C, is touchdowns divided by attempts times 20. And finally, D is 2.375 minus the ratio of interceptions per attempt multiplied by 25. So the sum of A, B, C, and D divided by 6 multiplied by 100 gives us the passer rating. So even though the range is 0 to 158.3, the best quarterbacks are in the range of 133.9, like Tom Brady, 115.8, like Matt Ryan, and Drew Brees at 104.7. But rather than just comparing 3 players, we're going to compare 10 players to each other for the 2016 season. Within R, I've prepared a data file called QB ratings. So the first thing I will do is I'll import this data set, but this particular file is already in Microsoft Excel. So I will go to Browse and access my file called QB ratings. Now you'll see that it already contains very neatly organized data, 10 quarterbacks, their team name, and then here are the 5 components that are going to be used to calculate the passer rating formula: completions, attempts, yards, touchdowns, and interceptions. Now, not part of this comparison is a column wins, which I've added, which is the number of wins for the 2016 season. Let's import that data, and what we are shown confirmed here that there are 10 observations, or 10 rows, 10 quarterbacks, and we are looking at 8 variables across those 10 quarterbacks. Now, the code in R that I have written contains all the calculations that are necessary to obtain passer rating. So the first step is to define the 5 variables that make up the passer rating score, and these are, again, completions, passing attempts, passing yards, touchdown passes, and interceptions. So because this data already exists in our data file, we'll begin with completions, the number of completions. So the command is QB underscore ratings $, which means referring to that column in this particular data file, and the column is comp. Now you have to be careful. R is case sensitive, meaning that you have to refer to the name of that column precisely in the uppercase and lowercase letters that it comes in. So if you break out this particular data file, you'll see completions is uppercase C, lowercase OMP, and that's how we have to refer to it here. So we're going to create a new variable called all uppercase comp. Okay, so I'm going to run this command, and you'll see that the comp value is created and it contains 10 records. Perfect. We'll do the same for attempts, number of passing attempts. Again, ATT is how it's referred to in the data file, so that's why we say ATT here. And we're going to create a variable that's all uppercase, ATT. Run that command and we'll see that it appears here. We'll do the same for yards. In the data file, it's capital Y, lowercase d, lowercase s. We're creating a variable with all uppercases, YDS. TD is already in uppercase, so we'll keep it that way, but we'll train R to now identify this variable TD with a source coming from the data file, and finally INT. Now you'll see that all 5 variables are complete. In other words, there is no missing data. So we don't have to do any additional steps to eliminate missing data. The next step in all of this that's highlighted are the equations for each of the passer rating components. Now, this is 4 passer rating components. The components are A, B, C, and D. Now, A, as you saw from the PowerPoint presentation, is an equation that takes the ratio of completions and attempts, subtracts 0.3, and then it multiplies all that times 0.5. So this equation, we're going to now assign it the lowercase a. So we'll run that command, and you'll see that lowercase a now is a calculation, a result of the calculation of completions divided by attempts minus 0.3 times 5. Same idea for B. We'll run this command. You'll see that B appears here, and now it's a calculation, a result of that calculation. Same thing for C, and finally D. So now we have the 4 components of the passer rating formula, which I have written down here. So passer rating is the sum of A, B, C, and D divided by 6, all of that multiplied by 100. So let's run this command, and you'll see that PR is created here now. And these are the actual passer rating values. Okay? Now, what we're going to do is, because PR did not previously exist in my data set, you'll see here that I have QB ratings, there is no column called PR, no column called passer ratings. So what we're going to do next is we're going to create that column and add PR into my QB ratings data set. Okay, and this is done by adding the brackets, quote, PR. I'm going to run that command. And just to confirm, there are a couple of ways to do it. We'll see that previously there were 10 observations of 8 variables, but now there are 10 observations of 9 variables. That was done by adding the variable PR. I can also expand this, and PR shows up here where previously it was not. A third way to confirm that is if I view the QB ratings file and I run this command, PR is now a column in this table. Okay, great. Now what we're interested in looking at next is who has the highest passer rating. So just by eyeballing this table, we see that Phillip Rivers from previously the San Diego Chargers, now the Los Angeles Chargers, had a passer rating of 99. And Joe Flacco from the Baltimore Ravens had a passer rating of 75. That's the lowest in the group. So what we want to do next is actually begin the sorting process. So here in row 55, I'm going to create a new data file called QB ratings sorted, which comes from QB ratings. It's the file, the table that we were just looking at. So by running that, you'll notice that a new data string is created up here, 10 observations, 9 variables, which includes passer rating. The next command is the key one that is going to sort the QB ratings file by PR. Okay, and it's done using the order function. Okay, so let's run this. And what we want to confirm as the next step is to ensure that the data were adequately sorted. So we're going to view the data again, okay, just to confirm that they were sorted. So I'm going to run this command, and you'll see now that the names were rearranged by passer rating value. So the highest passer rater is Phillip Rivers, as we had learned previously, and so he is shown at the bottom. And the lowest passer rating is Joe Flacco, and he is shown on the top. So this helps us identify the ranking. Who is the best, who is the worst of this particular subset of NFL quarterbacks. Okay, the next thing I want to do is I'm going to define a variable called QBs, because I'm going to use that information for my plot in just a few steps. So if I run this, you'll notice that QBs appear here, but by running it out of the QB ratings sorted file, I'm now creating a variable that is ordered differently from before. Now they are ordered in sequence of passer rating from lowest to highest. Remember, Joe Flacco had the lowest passer rating. This is important because when I create my plot, I want the names to show up in order from worst to best. So let's view what this looks like, just to confirm. Joe Flacco should be listed first, and Phillip Rivers, who had the highest passer rating, should be listed last. Okay, now let's create a plot. We're going to plot the passer ratings here in row 71. I'm going to run each line at a time so you can see how it creates the plot little by little. Okay, so we're going to run the first command, which is creating the plot for passer ratings out of this new sorted file. Okay, and we're going to leave out an axis and label it QBs. Okay, so you'll see that there are no axes, there are only labels, but the data are displayed here in sequence from worst passer rater to best passer rater. The very next command, axis 2, creates the y-axis. The very next command, axis 1, which is the horizontal axis, will actually display the list of quarterbacks in sequence in which I just defined them, which is QBs. Remember, QBs are a new sorted version of the names of the quarterbacks. LAS equals 2 actually allows me to display the names vertically instead of horizontally. And this is important because when the names are written, if I was to display them in the default horizontal format, they would run into each other. So it's better to display them vertically so that they don't run into each other. You'll see here then all the names are listed for the quarterbacks. Joe Flacco is first. He had the lowest quarterback rating. And Phillip Rivers is listed last because he had the highest quarterback rating. And so you can see just by looking at this list, Phillip Rivers is followed by Matt Ryan, followed by Drew Brees and Andrew Luck. Now the very next command is completely optional because we could leave the plot as it is now. But by adding the box command, it actually draws a box around the plot. So let's see what that looks like. It makes it look a little bit neater, although it's not required. So at this point, we've answered the first statistical question, which is which quarterback has the highest passer rating. But one additional question that I was curious about is what the relationship is between passer rating and wins. So you remember that in my data set, I have already added the wins column. So even though Phillip Rivers had the highest passer rating, his team only had 5 wins. However, Matt Ryan had the next highest passer rating, and he had 11 wins, more than twice the number as Phillip Rivers. And in my mind, even though passer rating is an interesting way to look at a quarterback, it only really grades the quarterback on their ability to create passes and create touchdowns. It doesn't necessarily grade them holistically in terms of how they got their team down the field and how they got their team to win. So we're going to look at the correlation or the relationship between wins and passer rating, and this will be an interesting observation, I think. So in row 77, we're going to create a new variable called wins, which comes from the column wins, $wins, in the data file QB ratings sorted. Okay, so let's run that. And we can either view it with our command, or we could just look to the right. The data, the number of data points are small enough, only 10, that we can actually, they all fit here in this side. Okay, so we have the variable called wins. We have obviously passer rating. So the very last process that we want to entail is from rows 80 to 96. Now I'm going to go slowly through this because I am introducing some new features in the plot. So as soon as I run this plot command, it's going to override the plot that we previously saved. So you can either save this by hitting the export and saving as an image or as a PDF, or we can just overwrite it, and I'll show you in a moment just how we can reaccess that, because it actually doesn't get erased, it just gets put in the queue. So the objective starting in row 80 is to plot the passer ratings from 2016 against the number of wins in that season. And we're going to create some solid dots instead of some hollow ones like you see in the existing plot. And we're going to actually make them slightly bigger than the default. We're going to make them about 30% bigger, and we're going to color them blue. Okay, so here is sort of the default settings of how the plot is created in R. We're going to add some additional features. So we are plotting on the x-axis is passer rating, on the y-axis is wins. And what I want to do is do all this extra features so you can see what that actually looks like. Okay, so I'm going to run this command. You'll notice that a couple of labels have been added. The main label that's going to show up on the top of the plot is quarterback rating against wins in 2016. And then the x-axis label on the horizontal axis will be QB rating in 2016, and then the y-axis will be wins in 2016. And that matches this x and y matches my x being plotted and my y being plotted. Okay, so let's run this and see what it looks like. So here are my labels. Here are my x and y labels. And now you'll see that these dots are a little bit larger than the default size. They're also filled in and they're also blue. Okay, now the additional thing that I want to do, actually two more things I want to do, is label these individual dots with their respective quarterbacks. Okay, so we're going to do that next. This is done with the text function. And the labels are coming from QB ratings sorted $quarterback. And I'm adding some additional features to that. I'm making the font a little smaller than normal by saying it's 0.6. Again, the default is 1. I'm adding a position to it relative to the data point, and I'm coloring it red. So let's see what that looks like. So there are the names of the quarterbacks. Okay, and again, the number, the QB rating. Remember, Drew Brees was the highest. Okay, but he had only a few wins. Now let's add a line, and we're going to do this by running these two simple commands. LM wins as a function of PR, and then a line, a green line that goes through it. Okay, so let's run these commands in sequence, and you'll see that a green line appears that shows that, you know, as quarterback rating increases, actually the number of wins decrease, which is counterintuitive. You would expect quarterbacks who have a higher rating to also have more wins. But interestingly, in this subset of these 10 quarterbacks, and there are more than 10 quarterbacks in the NFL, of course, so the result might be different if you include more data. But of these 10 quarterbacks, the result is counterintuitive. Now, again, there are many other reasons why teams win or lose, so it's not just about the quarterback. But the quarterback arguably is one of the most important players on the field, so you would expect there to be some relationship here. So this is interesting because I think if you did this analysis for a slightly different year, or maybe for a more complete set of quarterbacks, you might get a different answer. But the point here was to showcase some of the features that the plot can provide, instead of just creating the simple plot with just circles and minimal labeling and no lines. I wanted you to see some additional features that could be used in R. Now, I mentioned that this plot that we created overwrote the previous one. Well, it turns out the previous one is still available. If you hit the back arrow here, you can access the previous plot. If you hit the front arrow, you'll go back to the second plot. So these are still somewhat saved in R, but once you close your session, you will lose these unless you save them by using the export function here. So I hope that helps understand how we can look at quarterbacks, and we can look at some of the relationships that exist beyond just what the quarterback rating metric is measuring.